morning. Let me continue on pile foundation, and we have discussed several aspects of pile foundation. Particularly, most important part is that estimation of pile capacity, and that we have done. And pile capacity means how one pile, how much load can take, and also pile cannot be used in single. Most of the time it will be used in a group, and because of that what will be the group capacity, that also we have discussed. And finally, another important aspect of pile foundation is that, or any foundation, not only pile foundation, that you have to limit the settlement, and that also I have mentioned that for a single pile settlement is that settlement of group pile is much more than the pile group settlement. And again, when a pile group settles, there may be of several components, and there may be elastic settlement, there may be compressible settlement or consolidation settlement. So, all those things we will discuss one by one, and particularly since it is pile used in a group. So, we will discuss more about a group, and again group will be installed in different types of soil. So, accordingly the settlement calculation also will be different. So, we will show that one by one. So, let me take the first slide, that is pile settlement, and that too, this is actually you can say elastics. So, I forgot to mention, this is suppose elastic settlement of the pile. That means, pile itself will be shorten because of this compressive loading, and it will have three components. Actually, you can see here, that is S equal to S 1 plus S 2 plus S 3. There are three components, and this summation of these three components will be total elastic settlement, and they are explained one by one. S is the total settlement, and S 1 is the elastic settlement of the pile. Because of the loading, pile directly settles some amount, and S 2 settlement of pile caused by the load at the pile tip. And when there is a end bearing and friction pile, there because of the load transfer mechanism, some load will be transferred to the tip and some load will be transferred to the surface. So, because of the load transfer at the pile tip, because of that whatever settlement, that is S 2, and settlement of the pile caused by the load transmitted along the pile shaft. That means, if this is the pile, and then your this friction, because of the friction load continuously, there will be some shortening. That means, how to find out that shortening. So, I will not go in detail, but if this is the one loading, and if I apply load like this, then this can be easily estimated settlement P L by A E, because stress at any point is constant. But this type of loading, actually how to find out? You can imagine that this is section, and at that section, this is a small section you can take, suppose here, and on that small section, what is the load? Actually load will be actually frictional force here, whatever, because of this frictional unit friction multiplied by the frictional surface, the total load will be acting in this section. So, accordingly the stress, and because of that stress, what is the compression. So, that is the way one can calculate, but detail I will not go. Actually, I just try to use show the formula how to calculate because of this, and all. So, these three parts, as I have mentioned, will be showing one by one, and next I will go to that different component. You can see here it is shown the elastic settlement S 1, and this is because of the Q W P is the total load carried at the pile point under working load condition. Okay. And then there is a Q W P L by A E. This is just elastic formula from the strength of materials. If I leave this one, then Q W P into L divided by A P E P could be the settlement of the elastic settlement of the pile. But there is a provision here kept epsilon time W Q W S, that means the frictional force distribution, how it is a uniformly distribution or if it is a parabolic distribution or a linear distribution like this, accordingly this value introduced and accordingly it can be taken. So, you can see here that QWS load carried by friction under working load condition, and AP is the area of the pile, EP is the modulus of elasticity of pile and length, and epsilon value, that means these two, out of these two component actually you can see that how this friction because of the frictional resistance how to incorporate. You can see this depend on the friction resistance distribution of loading along the pile shaft. If this is the type of distribution, then you can take 0.5. If this is the type of distribution, then also you can take 0.5, and if this is the type of distribution, then you can take this as a value of epsilon. So, then so this is actually because if I leave this one, this is just like this, because of this if I leave this one, this is just shaft. If this is shaft, if I pull or push, then because of the elastic property it will settle, that much is this one, and this is actually because of the additional frictional load how it is coming, and that frictional load will be vary from top to bottom to top, and so because of that this will vary also, but that average value has been taken by this equation. Now, go to the next slide. This is S2, you can see the S2 actually given the formula QWPD diameter ES 1 mu square by E, that is actually your elastic settlement formula. Actually, because of that your if there is a loading footing loaded, then you know that what will be the settlement, elastic settlement. So, based on that, this is the soil at the bottom, at suppose this is the one, this is the one, and if I apply load and then bottom there will be pressure. So, because of this pressure and what will be the settlement of the elastic settlement of the soil below, that is actually from the footing we have done the elastic settlement of the soil. So, similar formula actually QWP d by Es 1 minus mu square IWP, this is the influence factor, and you can see here point load per unit area, and that is the one, and then d is the width of the width or diameter of the pile, and Es modular elasticity of soil. Previous formula actually have taken modular elasticity of the pile material, here actually soil, mu s is the Poisson's ratio, this should be capital, and this is the influence factor and alpha r, and which can be taken from this diagram, and alpha equal to 1 for circular footing, alpha average 0.85 and alpha maximum equal to 0.88. So, this is the for circular foundation, but otherwise we can find out from alpha average from here L by B versus this value. Okay. So, this is that means because the pile compression, and this is the compression of the pile tip, soil compression, elastic compression of the soil below the pile. So, that is the second part, and third part you can see S3 actually again that is because of the soil compression only, and you can see the how you will differentiate whether it is soil compression or pile compression is based on this actually what modulus value was taken. So, Q is the frictional force, PL QSW PLES 1 minus mu square by Es, this is actually another component. Because of the friction the side soil also will compress, and because of that also entire thing will also will foundation also will compress. So, because of that this is third part is taken, and L is the embedment length and P is the perimeter of the pile, and then IWS the influence factor, which can be calculated by this equation. So, S1, S2, S3 all together actually you will be elastic settlement of the pile. That means the elastic settlement will also can have three different ways. Actually the pile itself compress, then because of the load transfer at the pile tip, the soil below elastically will settle, and also when pile load transferred through the friction from the side of the pile, then that during transferring that elastically also will settle some amount. So, all three together will be total elastic settlement of the foundation, pile foundation. Okay. So, next I will go to next slide. You can see that as I have mentioned that settlement of the group pile is the most important, because this has to be settlement generally will be very large. And here actually you have to model if it is a pile on sand and even it is a group that I will discuss later on. Most of the time pile can be different ways. Pile can be up to this portion is suppose sand, and there may be somewhere your better I will come that one later on. So, let me consider that this is a friction pile particularly under cohesive soil and is uniform throughout. That means, this zone and this zone the soil is same. That means, up to a great depth soil is uniform cohesive soil, and in that case pile group will be considered as a equivalent draft at a depth equal to 2/3 of L. So, if it is this is L, if this is L, then at 2/3 L depth we will assume a equivalent draft, and then based on that equivalent draft I can find out at any point, you can find out any point what is the delta sigma pressure increase, and that pressure increase will be equal to load divided by width at this. Suppose I want to find out at this point what is the area of the cross section area of the distributed load. So, this distribution we have shown in the shallow foundation. If this is a B here, then B plus Z 1 will be here. Similarly, if it is B here other direction, it will be W plus Z 1. So, W is this direction. So, B plus Z 1 into W plus Z 1 is the area at this level. So, load divided by area will be your pressure increase, and this is the first thing you have to do. That means, because of the loading in the pile, how much increase in pressure in the layer itself, in the compressible layer, and then before loading what was the effective stress in the soil. So, that actually what you have to do, you have to consider, suppose I want to calculate at this point. So, I have to calculate what is the weight of the soil, effective weight of the soil up to this depth. So, if there is a layer actually, if suppose water table is here, then you have to take dry unit here, submerged unit here, unit weight here, and then you have to find out sigma dash sigma v dash at this level. So, it was sigma v dash was there originally before applying load, and then applying load del sigma is there, and if you know that present loading and past loading, and if you know the soil properties like CC void ratio, then we can find out by log formula the settlement consolidation settlement of the group, and that is actually CC multiplied by H1. H1 is nothing but a thickness of the layer. If it is from here to here, suppose I want to find out this thickness is H1, or if some other depth actually there is a layer. So, that whatever thickness of the compressible layer, that I will take as H1 log 10 base P1, or you can say this is P1 plus del sigma. P1 was we can say this is I have not changed. So, this is nothing but P1 means sigma v dash I can say, and yes, this is also sigma v dash, and this is delta sigma, that is because of the loading what is the pressure. So, sigma v dash plus del sigma plus sigma v dash. So, that is log, and then if you calculate this one whatever will be there, that will be consolidation settlement of the layer. And so, what is the case actually here? We have seen that the pile is driven in cohesive soil, suppose that is frictional pile, and is uniform up to certain great depth, and in that case what we assume? We assume the at one equivalent draft, this is the pile cap, and this one I can assume at a depth equal to 2/3 of length of the pile, and then from there I will see this all are compressible layers. So, if there is more than layers actually we can divide into more parts, but otherwise if it is a single layer I can find out middle of the layer what is the width of the footing and what is the length of the footing, and based on that I can find out delta sigma. And at this point before applying load, what was the effective vertical stress before applying load, which is nothing but the weight of the soil. And weight of the soil, when there is a water table we have to take submerged unit weight, when there is a dry or above water table we will take just total unit weight. So, based on that I can find out sigma v dash here, and then I can calculate delta H equal to C C H 1 1 plus E 1 log 10 sigma v dash plus del sigma by sigma v dash. So, this is already elaborately we have done in shallow foundation, same formula only we will be using for calculating the consolidation settlement of this layer under this pile group. So, this is one type of thing, that means, when we will see the pile group and the soil profile, based on that you have to first model the system for calculating the foundation. This is one model, that means, when the piles in uniform soil, that means support from friction and end bearing both are there, assume an equivalent raft at 2/3 of the pile embedded length. That means, if the embedded length is L, then 2/3 L depth, actually you have to consider the equivalent raft, and based on that I have to calculate this, I have to calculate this, and then I have to use this formula to find out the consolidation settlement. Next, I will go to the another case. Actually, you can see, of course, as I have mentioned that even for group also there will be consolidation settlement if it is a compressible soil, and in addition to that there will be elastic settlement also for the group, and elastic settlement will happen because you can see that throughout the length, actually since friction is there, then there will be elastic settlement of the soil, but here we will consider since we have considered the raft here. Okay. So, beyond that, from here to here we have considered the consolidation of the soil, okay, consolidation of in this zone. So, this zone actually soil also will compress because of this friction. How to calculate that one? You can see here, this is there Q design JD. JD is nothing but that where actually you are considering this is JD, where you are considering this, that means this depth of soil will be compressed under friction. So, because of that depth will be taken, and AE, and A is the cross sectional area of the raft, and also E is the actually soil modulus to be taken, because so this is the one actually the elastic settlement. So, if you add this with the consolidation settlement, whatever we have done, that will together will be your total settlement. And so, this most of the time this very frequently we use, but this is one thing that is a one component will be there, that will be comparatively smaller, but one may do or may not do. So, just for that it is I am showing this equation. Otherwise, that when there is a pile driven in compressible soil, then consolidation settlement calculation become more important. So, that is there is whatever I have shown in the previous equation. Next one, actually you can see this is another type of system that I have told you that for calculation of settlement you have to model the pile soil system, and one model we have done, I have shown that when the pile is embedded in uniform friction pile and that too cohesive, then you have to assume an equivalent raft at a 2/3 length of the pile. But if the soil is either suppose this is actually this zone is suppose sand, this zone is sand, and then the pile will become this zone is sand, and somewhere there may be some compressible layer is there, or if this is soft clay and this is a stiff clay, then there will be chance of having end bearing. So, under this situation, that means this is soft clay and this is hard clay, that is one situation, or if it is sand and there is a clay somewhere here, under these two cases you have to assume an equivalent raft at the pile tip, and you can see here at the pile tip equivalent raft is considered, and after considering the equivalent raft here by using similar procedure, that means taking a dispersion of the load, 2 vertical versus 1 horizontal, then we can find out width of the footing at any depth. So, that is B plus Z1 and W plus Z1, like the way I have shown in the previous one, and based on that I can find out Q divided by area. So, that will be delta sigma. Okay. So, that means previously what we have done, we have considered equivalent raft at 2/3 length of the pile at a depth 2/3 length of the pile, and here actually when the pile embedded in steep soil, then you can consider that is a the entire thing is transferred at the pile tip, that means end bearing type, and then you have to consider the equivalent raft at the pile tip, and then from the pile tip up to the compressible layer we can find out what is the width and then what is the length, and based on that what is the delta sigma because of the additional load on the pile. This we can calculate, and also we can calculate what was the before applying load, what was the your effective vertical stress, and suppose if that is the point, if you want to find out the effective stress, then vertical effective stress, then you have to consider soil weight up to this entire depth, soil weight up entire depth, and if in between water table there, then you have to above water table you have to take total unit weight, and below water table you have to take the submerged unit weight, and based on that you have to find out delta sigma v dash, and once you get the delta sigma v dash, we can find out the delta h, that means settlement will be equal to C c h 1 plus a log 10, and this is actually instead of p we can say sigma v dash, this is also sigma v dash before applying load, and this is the delta sigma after applying. So, this is actually this sigma v dash plus delta sigma, that is the effective stress after application of the load through the foundation, and this is actually effective stress before application. So, that P 2 by P 1 actually, that is log formula. So, that same thing can be used, and one can find out the compressible consolidation settlement of the layer. So, that means this is a load, this is a model, that is actually you have to consider the equivalent raft at the pile tip. So, two options, whether at either at 2/3 height or at pile tip. Next one again similar to this, actually you can see here that elastic settlement also will be there. So, so this is the suppose steep layer, suppose this is the steep layer, and this the pile is embedded in the steep layer to have the bearing resistance. So, in under this condition we have assumed that the equivalent raft will be at this depth, but because of this depth between E is the embedded length, embedded in the steep layer, and the equivalent raft at the pile tip, suppose this distance actually sometime to be taken will be elastically settled, and for that actually you can find out another equation by similar to the previous one. Instead of taking entire length, you are taking only this length. Okay. And for how to find out this length, there are different recommendations there, you can see from the book. Generally 50% or 75% of entire length can be taken, and this formula can be used for finding out the settlement. So, this plus that previous one will be the total settlement of the group. Okay. So, let me go to the next, and when the pile is embedded in sand, suppose like this, you can see here that this is also sand, this is also sand, and then maybe no compressible layer close to it. In that case, entire settlement will be because of the elastic settlement of the group, and in that case, of course, in the literature there are number of formula available, but out of that, based on SPT correlation, this is the formula available in the literature. A little small variation also available. So, this can be used. How you can see what are those actually. You can see expression is given that delta H will be coming in inch actually finally, and this Q will be used in ton per square feet. Q will be used, unit of Q tons per square feet, and Bg actually Bg is what actually if there is a group, something like this. If this is a group, suppose, so minimum width. So, this is actually one dimension, that is our W, this is suppose B. So, two different width we are getting. So, there is a minimum one actually to be taken for calculating this settlement. So, minimum will be this one. So, Bg actually minimum width of the block, and how to get the block actually. As I have shown that you have to draw a tangent to the outer row of the pile, from this direction and from this direction, and then whatever area will get, that is actually your, from there actually you will get the width and length, and then q multiplied by under root b g by n, and b g actually is should be minimum width, first of all minimum width. So, that means whatever I have shown this and this, you have to take always this one, and that too unit is in feet, b g in feet, and q in tons per square feet, and n actually your the SPT number, and this if you put this all those things, and based on that we will get some value that will be expressed in inch, and that will be the elastic settlement of the. This is of course empirical totally, and such empirical, many such empirical equations are available in the literature also. Or if you have interest, you can go through this. And now, so that means we have now three different model. One is actually pile embedded in uniform compressible soil. That is actually in that case what we have to do, we have to consider the pile equivalent draft at 2/3 length of the pile, and then rest of the calculation like what is the delta sigma and what is the effective vertical stress before applying load, and then based on that one can find out the consolidation settlement. Similarly, another model was that if the pile is driven in compressible soil and finally rest on a stiff soil, then in that case the it will be modeled as equivalent draft at a depth at a pile tip, and then based on that model one can calculate what is the delta sigma, what is the equivalent vertical stress, and then finally using that log formula one can find out the compressible settlement. The third model is if the soil is embedded in uniform sand, in that case it will be there because of the elastic settlement, and that elastic settlement one can calculate by using this formula, and the delta is this is actually empirical formula, and it is unit dependent. Whatever unit mentioned here, same unit only you have to use, other than that if you use then you will not get the correct result. The outcome will be in inch, and q should be used in tons per square feet, and b g should be used in feet, and that too this b g is the minimum width of the group, and n is the SPT block count for the soil layer. So, with this I will stop here, and I will try to show you some numerical example to explain